Hello. A body is supported on a rough inclined plane by a string attached to the body and held at an angle of 30 degrees to the plane. Draw a diagram showing the forces acting on the body and resolve these forces horizontally and vertically. So this is our diagram. This is the slope, incline at 30 degrees. And this box here, this little block, represents the body. It has the forces acting are first, let's just articulate this. Forces, tension, of the string T, and that's acting at 30 degrees to the slope. These are all similar triangles here, so T acting at 30 degrees to the slope. The next force is the reaction R with the plane. That's called R. That's acting perpendicular to the plane and in the direction of this arrow. And next we have the weight of the body. It's W. That's acting downwards. And lastly, we have friction, F. Now remember, friction is always going to oppose, it's going to oppose any action, any force acting. And the tension is pulling the body up the slope. Friction will be acting in the opposite direction, so it's acting down the slope. Right, so now we're going to go ahead and resolve these forces. First we'll start with frictional force. It's acting down the slope, so if we use this to illustrate the force acting down the slope, F, then we can build our right angle triangle around this. This is 30 degrees, and our components, F cosine 30 and F sine 30. Make sure you get the arrows acting in the right direction. You remember this, the frictional force is the resultant of F cosine 30 and F sine 30. So they're acting in this way. The resultant must act opposing these two forces in this triangle. Next we have the reaction to, it's the reaction of the plane to the body acting upwards. So we have it this. Let's draw it a little closer here. So we have that as R, and our triangle comes along like this to give us this being 60. So we have this component acting in this direction, and this component acting here. So this is R cosine 60. This is R sine 60 degrees. Next, we have the tension in the string, and you have this acting upwards here, and this is T, and our triangle is this. We have this component which is T sine 60, and T cosine 60 degrees. This also being 60 degrees. Now, if you want to know why we have 60 degrees and not 30, if we were to just draw a dotted line here, we'll note that this is perpendicular to the body. This is this is running down the slope, so it's perpendicular to the reaction force. And so this whole angle here is 90. We know here, for similar triangles, this is 30. So this remaining angle here must be 60 degrees. And so that's how we worked out the angle for this, the reaction, and also similarly for the tension in the string. And lastly, we have the weight. This only has one component, and it acts downwards. Let's write that. Let's draw that a little better. W acting downwards. So there we have it. We have our components. All make sure the arrows are correct. Remember, here the frictional force is a resultant of these two components. The reaction force is the result of these two components, R sine 60 and R cosine 60. And likewise here, the tension in the spring is, oh, I've made a mistake here. Oh no, yeah, we do have the tension is here. T, yeah. Tension in the spring is the combination or the resultant of T cosine 60 and T sine 60 to give us the tension in the string. Our forces acting on the body, we've shown that there are four forces acting: tension in the string, the reaction force of the body on the slope, friction acting downwards, down the slope, and the weight acting vertically downwards. Thanks for watching. I'm Alistair.